So this has been something like a 15-year project since Geoff Rodgers and I were first engaged in it. And so this is a suite of devices. They're all about dissipating energy in the responsive buildings. The whole goal is to dissipate energy without having to have any damage to the structure, so you're back in business the next day. And you don't have to go inspect it, replace it, repair it, or anything like that.
Key thing is that all buildings are different. It's not like a conventional mechanical engineering problem where you might have a fixed design which then gets produced by the million. Every building is unique and bespoke and has a range of different land conditions, architectural function, and as a result of that, it's not necessarily a one-size-fits-all situation. Depending upon the particular requirements of the building, one device might be more suitable than another.
So it's been 3 places, largely driven by my colleague. The first was the Forte Health Building, the new hospital on Kilmore Street. The second is probably, I would say, the best known building in Christchurch at the moment, which is Tauranga, the new library. So there's a series of devices in there that was led and driven also in part by one of our former PhD students taking his research into practice along with the devices. And the last, which Geoff Rodgers can elaborate on, is a community housing project in San Francisco.
Actually met a consultant, David Ma from Ma Structural Design, at a conference in Japan, and he's a really innovative kind of guy. Had this project that was going on where he wanted to really go beyond just a code minimum building. This is a project, a really inspirational project, where 25% of the occupants will be formerly homeless, and then the remainder will be underprivileged, low-income families. And while it's not a traditional building that you might think of when you think of low damage and resilient design, actually those future occupants of the building won't necessarily have a strong social network or a large amount of resource available to them to reaccommodate in the wake of an earthquake if they don't have seismic resilience.
I think, like a lot of my research, for myself, I look to have an impact. So with energy dissipation and earthquakes, you want to make buildings low or no damage, but you need to do so in a cost-effective way. And as I said, economically this ripples all the way through the economy, and some of the least advantaged are some of the most impacted, not necessarily directly, but by the fact that there's less work or their housing is gone. So you'd like to make it so that these are low cost enough to be accessible for every kind of building, housing, this sort of area, so you want to have that impact. At the same time, it's a way to increase the resilience and reduce the impact on the economy of a region that's hit by an earthquake.
I think one standout moment for me was in April of this year. My brother, sister-in-law and niece were in Christchurch, and took them into Tauranga, and just seeing the joy that they got from that building. It's a fantastic public asset. Everyone involved in that project's done a fantastic job. There's a huge number of families there enjoying the facility, and to know that you'd contribute one small piece to that overall project was fantastic.
I'd like to see the technology get used. The more it gets used, the more people become familiar with it. The more people are familiar with it, the easier they see it to incorporate into whatever they're doing with buildings and other areas.